Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this video we are going to discuss this practical circuit design for CD4017. It is not just only for driving LEDs. Basically it is a decade counter. The frequency pulse applied at pin number 14 will shuffle output at each cycle. Let me explain. For example, if we see input, this is input to this circuit. At change in each cycle at pin number 14 will cause to shuffle the output to the next higher rank. So it is LED number 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. These 10 LEDs, each LED is connected through a current limiting resistor to the pin that is respective to Q0, Q1 to Q9. Q0 to Q9 it have 10 outputs and the 12 output that is carry output. When it will count up to 10, then it will give our output at pin number 12 to drive the next circuit. If we want to cascade, if we want to add more stages, but output at this stage will divided by 10. If here we are applying 10 Hertz, here we will find 1 Hertz. This 1 Hertz will provided to the next circuit. So each circuit will divide by 10. Pin number 16 is VCC, pin number 8 is ground. That is not shown here. We can apply from 5 volt to up 15 volt and maximum 18 volt because it is CMOS IC. CD4017. We can use in different projects, different counter stages. You can limit its movement whenever you want. If you want to calculate the LED, I am applying 5 volts. If you want to make this flasher circuit, I made this flasher circuit in video number 457, and you can adjust the time period from very slow to fast. You can check video number 457. We can see the blink rate is increasing. When I am adjusting this potentiometer, the blink rate is increasing. And each cycle will cause to shuffle the output stage. I applied 5.2 volt. If you want to apply some voltage other than this, you can do up to 10 volt, 15 volt. We supply, how much we have supply voltage? Minus VLED divided by ILED. I am using 5 volts, so 5 minus 1.8. I am using 1.8 volt for every type LED, but there are different type voltage. Red LED have different voltage, yellow LED different voltage, green LED, blue LED, any type of LED. You will calculate the resistor value according to the type of LED. So every LED must have a same light. So I am using 3 mm LED, so I am calculating at 10 milliampere. V supply 5 volts, 5.2 volt minus 1.8 volt LED drop voltage, and the remaining voltage will drop across this resistor. Pin number 14 that is connected to clock input. This white wire I take output from this clock circuit and I connect it to pin number 14. Pin number 1 that is cut side here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 is connected to VCC pin, that is 5 volt. Pin number 8 is connected to ground and it is connected to the LED grounds. We can use any square wave generator, any pulse generator to trigger this circuit. We need a clock signal, any signal which is going high to low. So first LED, green wire, it is connected to pin number 3. Second LED, I will mention here, this LED to pin number 3, this LED to pin number 2, this LED to pin number 4, and the fourth LED that is going to pin number 7, fifth LED in 10. The next LED, this wire, it is going to pin number 1, 5, 6. This blue wire is at pin number 6, and then we have this wire, it is going to pin number 9, and the last one, that is 11. Just only one pin there is still not connected, that is pin number 12. And if we want to drive the next circuit, that is called carry output, that is pin number 12. So this is pin configuration. Pin 16 is VCC, pin 8 is ground. We have some different controls. Pin number 15 is master reset. Normally it is connected to ground. Then we have enable circuit. If enable pin is connected to ground, this chip will work. If we will remove from ground, this IC will stop working. Let's stop it. So that is pin number 13. So pin number 13, that is here. If pin number 13 is not connected, it will do some random behavior. If we connect it to ground, it will work normally. And if we connect it to the VCC input, then it will stop. Now it will not work because we disabled its function. That is chip enable. In CMOS ICs, most of the time there is chip enable circuit. This IC now in standby mode. We can disable this IC by any type of input, from any gate, from manual input. So this is function of pin number 13. And then we have pin number 15. That is master reset. I removed this pin from ground. This IC is stopped now. Master reset, I removed master reset, pin high. Now it went to pin number 1 and stopped. Anytime we want to reset this IC, we will connect this pin to positive. So it will go to reset mode. So it is its reset. Now it will start from 0. Chip enable or enable pin, that is just only to enable the chip, and chip will start from the last point, last known point. But master reset or reset switch, it will start this IC to a 0 line. Why we need this? I powered off this circuit. Now I will power on, and we will check from which stage it will start. It started from here. I will turn off again. It started from here. I will power off again. It is starting from here. Power off. It is starting from here. It will start from any random counter. From any stage it can start. Now it is started here. Turn off. If you want to start the sequence from 0, then we have to make a reset circuit which will disable its operation, and after a specific time make a delay time circuit, delay start or soft start circuit. So you can make a soft start circuit using a RC time constant. If you can make in circular style, you can make it easily. And if you want to integrate a big number of LEDs, you can use a switch, a MOSFET, and you can use this signal to drive that MOSFET, and that will work. To overcome this issue, for a restart, at power on, I made a restart circuit. I used an inverter of this CD4017, a resistor, a capacitor, 5 volt, 25k resistor, 100 nanofarad capacitor, pin 2 and pin 1. This pin 1 is connected to pin number 15. Now if you will power off and we will turn on again, it will restart from pin number 1 because it will give a charging time. Now we can see it is starting at pin number 1. Anytime we will power on, it will start from pin number 1. We can see now. Before this it was taking a random start, but now it must have to start from pin number 1. I hope so this video is informative. If it is informative, hit that like button. If you have any question, kindly let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.